Okay. Good morning. Welcome to lecture 21 for thermodynamics of materials. We are discussing assignment number 2. Okay. So we hope to complete this assignment today. So assignment number 2 continued. Let us move first. Problem is this. Problem 2. This I wrote last day, but it was 10 liters of monatomic gas at 25 degree centigrade and 10 atmosphere pressure. And 10 atmosphere pressure are expanded to a final pressure of 1 atmosphere. Calculate the work done heat absorbed and the change in internal energy U and H enthalpy for the gas. For the gas, if the process is carried out two different ways. The final state is reached two different ways, starting from the same initial state. One is what? A, maybe isothermally and reversibly. B, adiabatically and reversibly. This is your problem. Okay. Let us have the solution this side. First, you sketch the problem. This is the main thing. You sketch on the PV diagram. Let me draw this PV diagram. There is second part, but I am not considering the first part only. Okay. Second part I will discuss a little later. So let me complete this diagram. So start from the initial state. Initial state has no problem. Initial state, okay, good boy. Then it starts from 1 to say isothermally. So this is your state 2, isothermally. Give me an arrow maybe. So what is this? Okay, too many arrows, okay. So wait a bit. Since very good. So this is the isothermal. Okay, this you see. What is the status? 10 liters pressure is 10 atmosphere. Pressure 10 atmosphere PVT. If you go this way, volume is 10 liters and temperature is 298 Kelvin, 25 degree centigrade. State 1. This has been isothermally. So this is actually isothermal. Okay, what is the temperature isothermally to what pressure? So let us give this friendly. There are too many lines coming. Okay, so this is your 10 right here atmosphere. Your figure must be, okay, must explain things. Okay, so this 290, what is this? This is expanded to which pressure? It is given to you to 1 atmospheric pressure. 1. Have you solved this problem? How many? Raise your hands. Solve this problem fully. Only 3 students. What are you doing? Why? What's the difficulty? You could not solve. Then you have better days ahead.
The second part we have
Second part, no, first part. This part. They have solved. Oh, this part, whatever I have written. Have you solved? How many? Raise your hands once more. Oh, Amarto, what happens? Difficult. So, this is the hot pressure. It has been expanded to 1 atmosphere. This is given. Isothermal means temperature is same. 298 Kelvin, you may write. Then what is the volume? You can guess the volume easily. Because it is isothermal. You know, it is isothermal. So, pressure, if pressure is 1/10, volume will be 100 times, 10 times. Pressure down 10 times, volume will be up 10 times. So what it is? 100 liter. PV is constant. PV is constant is the isothermal process. Okay, this is the isothermal. Achha, this actually don't worry. This I'll give in. Come on. Then what you are doing? This is isothermal. Then what happens? You do the same expansion, same final pressure in a different way. What is the different way? Adiabatic. Adiabatic is what? Is a different path. Isothermal, you know, PV is constant, you know. You may write this. PV is constant if it helps you. PV is RT actually, RT, constant. And what is the adiabatic? This is the adiabatic. Steeper. So what is this? This is 1, 2 prime. So I am giving 1, 2, 1, 2 prime because this is okay. So what is the isothermal path? Okay, very good. Then okay, this is the adiabatic path. What is that? This is adiabatic. You write somewhere. Friendly write. Label it adiabatic. Means reversible adiabatic. All reversible adiabatic. And what is this? Adiabatic. Against the final pressure is same. What is the rule or equation for the adiabatic? PV to the power gamma is constant. Reversible adiabatic. So this is given to you. So what you have to find? Those things. Okay. One thing you have noted perhaps, you don't know the number of moles. Achha, let us try and then you will see N is coming into the picture. What is the first thing? Work done. Isothermal. So start solving A. Is the isothermal and reversible? Isothermal. Reversibly I am not writing because I am actually saving time on them isothermally. What is this? So first work done for you. You know integration, you know all these things, PdV from state 1 to 2. Okay. You know what is this? PdV is finally nRT by V. Okay. nRT, I am not writing all these things. nRT ln V2 by V1. But N you don't know yet. so find out N at the very beginning, no problem, because initial state contains PVT, means N can be found. Remember, any 2 or any 3, the fourth can be found always. Sometimes moles will be given, pressure, temperature given, volume can be found. And similarly, so N is PV by P1, V1, nRT by RT1. What is this value? Put the values. P1 is what? 10 atmosphere. 10 atmosphere. What is the volume? 10 liters. If I see correctly, R must be consistent. Liter atmosphere, 0.082 liter atmosphere. I am writing for the time being, but later on, mole is since it is in mole Kelvin, and T is what? Temperature 298 K. If you do this job, you will get. You start from here, you will get. Actually, you try yourself. Is 4.01. 4. I'm sorry. This 4.09. 4.09 mole. So, working substance is system is 4.09 mole of an ideal gas, monatomic. Monatomic is written somewhere, perhaps I've written maybe monatomic. Okay. Very good, quickly. So N, so start N will be, actually it was intended to be 4 moles. But anyway, you know, always it will be some decimal, and 4.09 you write, whatever it is. R is what again? R, what unit of R? Because this is, you will have to work down all should be in joules. So 8.314. Make no mistake here. See, a moment ago 0.082. Next moment 8.314. You have to be very careful. Otherwise, you'll be screwed up. You just simply cannot imagine what will happen. Now there's time. Careful. Why not, sir? Why this, sir? Because I want to, the only liter atmosphere will be consistent to the mole. If you put 8.314 joule, it will not be consistent. Okay, so but here again, since your answer should be joule, so start from here. V2 by V1. What is the volume? You have seen V2, you see. V2 is 100 by 10. So what it is, if you do this correctly, then you get a nice answer. Is this 23.233333 joule? You'll get this. You do this yourself. 23, and so this is nothing in kilojoule, since it's a too big a unit. So make it convert into kilojoule. 23.33 etc. kilojoule. So one answer out. So I'm giving a tick mark. Means this is over. So delta E, this W. Okay. But at the same time, you can write Q is for isothermal process. Advantage Q is W. That chart you follow. Q is W. So same answers, sir. Same answers, sir. No trouble, sir. No extra difficulty, sir. Out. Sir, delta U for isothermal process, 0, sir, a function of temperature. Delta E. So this is good. I am not actually writing anything. Very good. Then it saves time. Isothermal NCB delta T. NCB CB delta T is 0. So, very good. Do this. This part is over. So this part is isothermal reversible completed. And adiabatic now. Next is adiabatic. So what shall I do? N is 4. I am removing this part. Removing this part. I think you will not mind. You will not mind at all. So solution continued. Right here only top. N is 4.094. That will be useful. Start. Adiabatic. Adiabatic. What is the difficulty? What we know. Starting state known. Because they are starting from the final state. What we know and what we don't know. What we know? Pressure. 1 atmosphere. Both have the same pressure given here. So volume we don't know. Final volume and final temperature we don't know. For which we have handy equation. P to the power gamma is called solution. Right here, second is B, adiabatically. For adiabatically, remember, and reversibly you write once more, no problem, because adiabatic is very cautious. Reversibly. Happy? Quickly and very quickly. Very quickly and very quickly. So what is this? First of all, finally, you have to, first of all, since it is better actually we do this. Do this, okay? Okay, what is this? Actually, suppose you start simple-minded approach. Sir, delta U, sir. What is the first thing? Work done. Let's try first. Okay, suppose you think actually you don't need any more data or any more derived data. Quickly, W, suppose you have started. For the adiabatic. Adiabatic is 1, 2 prime. You say 1, 2 prime, not 1, 2. So what is this? Adiabatic. Adiabatic. Okay. 1, 2 is what? What you will do? Okay. Let us do one thing. What is this? You know this. Okay. Delta Q1, 2 prime. You know that is also. Delta U is what? Please tell me. N CV T2 prime minus T1 may be better. This may be better. Write all. Is NCP T2 prime minus. So you need to know T2 prime. Actually, but you actually use T2 prime can use. You could do these things. Adiabatic, reversible adiabatic. Here, what? Reversible adiabatic. To find T2 prime. Quickly find V2 prime first of all. P1 V1 to the power gamma is P2 P2 prime gamma. What am my intention? I will get V2 prime. Then once V2 prime known, P2 prime known, moles known, T2 prime known. Okay, V2 prime maybe it is better do this. Okay, because it is simple than TP relation. Good boy. So or V2 prime is what? Write this. V2 prime is what I'm writing. You follow me. One line do. V2 prime. P1 is what? 10. I'm not giving the answer. V1 is what? 10. P1 V1 10. Power what? Gamma is Cp by monoatomic. Cp by monoatomic. C by 2 or 5 by 3. Oh, you know this? 1.67. 5 by 1. Cp by Cp. Okay, so V2 1.67. Okay, 1.67. So P1 V1. This is what? Divided by P2 prime. P2 prime is 1. 1 atmosphere. P2 prime 1. Then this is what? This is what V2 prime gamma. V2 prime gamma. Power gamma. So V2 prime is 1 by gamma. 1 by gamma means 3 by 5. 3 by 5. Very good. This you would do yourself. You'll find your answer will be. I have done this. I have issued them. I have some of you. 118 point. I'm very sorry. Is 39.81. Have you got this? Anyone? Close to 40 liters. Okay. Does it tally with your expectation? Now see what? See, this will be to the left. The volume will be less than 100 liters. Yes, sir. If it exceeded, then you knew that there are some mistake. So, but you are happy. V2 prime. Then the goal is what? To find what? T2. What are you doing? T2 prime is what? Tell me. So, right? V2 prime PV by nRT. Okay. nRT. Okay. nRT. T2 prime. Okay. P2. Oh, T2 prime is P2 is what? I'm sorry. nR T2 prime. You apply this. So you know this. Get out T2 prime as what temperature would be very good. T2 prime is 118.6 Kelvin. 118.6 Kelvin. Again, tell me, is it? It is. Starting is 298, final adiabatic 118.6. Expected? Because it is adiabatic cooling. Because work done by the system at the expense of internal energy or temperature. So expected. If it exceeded again 298, go back to your calculations and considerations. So now substitute. No waste. N is again, suppose I am showing 1. showing one, you do the others. N is what? Again 4.09 cent system. CB is 3 by 2 R. R is you know. T2 prime is what? T2 prime, right? Okay. Since can I remove this? T2 prime is written here. Okay. Right. T2 prime is what? I will remove this soon. What is T2 prime? Is right. T2 prime is what? 118.6 Kelvin. Now it's time to remove this to make a room for writing. 118.6 T2 prime minus what is the T1? Obviously 298. What is the unit of R here? Again, unit of 8.314. Recall this. Oh, sorry, sir. R is cancelled as. If you do this, what you will get? Answer is remove this. Answer is you will get a value minus. I'm writing here. Remember kilojoule. Have you got anyone this value? Okay, good boy. Delta E should be what? Similarly, instead of CB, it is CP. In 5 by 3 times this answer. CP is 5 by 2R, 3 by 2R, 5 is to 3. So it is 5 by 3, but you can do it full again. You do CB, you know, CP. Right here, 3 by 2. Okay, 3 by 2. Right, CB is 3 by 2, right somewhere. 3 by 2R, and CP is monoatomic. You know this all. Monoatomic ideal gas. CP is 5 by 2R. So substitute this and get the answer. Let us not waste time. Will be minus 15 point. Good boy. Yes, it's satisfying that some of the students have answered this. A handful. Over these two over. What is not over? What is this value? What is this value? Your name? Your name? Tanmoy. Tanmoy, what is this value? Q. No, no, why are you looking away? So look at me. Next. This one. Q. 1 to 2 prime. This is reversible adiabatic. Your name I know. You. Yeah, কি নামটা? সব্যসাচী Q. For reversible adiabatic Q, heat interaction between system and surrounding. Are you? The answer G is 0. Then I'll be happy. You don't have to say since it is adiabatic, but that is understood. 0. Correct answer. So 0. For adiabatic means no heat interaction. Insulation. W1, what is this? You know very well. You know W prime is, since first law minus delta U, first law, right? Somewhere right first law, that will be always useful. Huh? First law. So just keep it handy. First law. First law is Q is delta U plus keep it before your eyes. You'll get some strength. This relation. The relation means weakness. Relation means weakness. Weakness of the problem, not yours. This will exploit. Verily. Remember, any relation means actually your advantage. What is this? Any two I know, the third I find out. Here similarly, since Q would be W minus, because Q is 0, minus delta, what is the answer? Delta already found to be plus kilojoule. Okay? Answers. Okay? Answers. Over. Okay? Yes, again tell me, did you expect this? Work done plus? Let us see. Amor will tell us. Acha, you tell us. Devapam, work done plus, did we expect this? It is plus, maybe calculation is all correct, but is it plus? Did you have any expectation about this sign? Work done?
It's something that area under the curve.
So who will measure? I cannot know. Can you measure?
I mean, it is.
It means, so what? Now what I'm saying, did you expect this plus value? See, 9.15 I am not arguing. The plus expected or?
I'm saying that since the area lies in the positive quadrant.
The area, there is always an area. In negative also, compression also, other things also, there is negative. This is actually work done by the system, expansion. 3 things I said. See, is everything, every statement that I made, every help I gave you, just use them. That work done by system, expansion, work done by system, positive. See, if I help you, does it inconvenience you? That this is so thumb rule, quick. So it should be positive. Area under the curve, or negative also area under the curve. Area is area, that is numerical value. Compression, suppose this is compression. This is compression, suppose. This is compression. Then also area same. But negative only. PdV, I am telling you, expansion, pressure, dV is the volume change, is a positive. Wasting time. Okay? The time is money. Happy? All over. First, second, two problems are over. Very good. Now it is time to rub them off. Now, remove this. Quickly. Remove. Clear. Then actually, second part is interesting. Actually, it says, next, I'm writing, second part. Next, by the way, I may forget, note, this is taken from, this problem taken from D.R. Gaskell. From D.R. Gaskell book, from what is Introduction to Thermodynamics of I told you materials. Materials. Is even in the problem sheet? In the problem sheet, do you have any on problem sheet? Introduction to Thermodynamics of Materials. You see here. Material by D.L. Gaskell only written. It's second edition. By D.R. Gaskell. Happy? Okay. The next part also taken from this. Next part of the problem. This is more of discussion than numerical calculation. What is this? Written here, it is given here. Okay. Achha, I am giving you what it is. What it is. Achha. So that delta U 1 U is a state property. Delta 1 to 2 prime. This is essentially this what I am written there, but you see delta U 1 to since so that you correct me, so that since U is a state function, you know, delta U 1 to 2 prime is adiabatic. What is this? 1 to 2 prime is the adiabatic path. You see, is what is same irrespective of the paths. Combination of paths, maybe not bad. If the combination of paths taken between states 1 and 2 prime. Okay. For example, okay. As for any combination of path. Okay. Combination of the following paths. Combination of the following path may be better. Of the following paths. Of the following path. Path I am giving you one by one. So A. Okay. So one say. What is this? What is constant pressure? I'm very sorry. Isothermal followed by constant volume. Okay, I'm correct. Constant volume. Two combinations. Isothermal followed by constant volume. Okay, what is this? I'm showing this. Also, see, you have to 1 to 2 prime. All cases 1 to 2 prime. 2 prime. This focus here. Focus there. So how isothermal? This is adiabatic. So isothermal, maybe this isothermal, not bad. Then constant volume. So what it will be like? So 1 to A to 2 prime. 1 to A to 2 prime is as good as 1 to 2 prime. So what is this? One path is 1A 2 prime. Let me write on the top. Reversible isothermal alone. Reversible isothermal 1A2. And reversible adiabatic is what? 1 2 prime. This is already. We have seen this already. Now as a combination, what is 1A 2 prime? So this is your isothermal. Shall I show here? This is your isothermal followed by name suggest. Okay. You have delta U. Delta would be same. I am showing you how it is. Suppose 1 to A, you calculate delta U. Is 0 though. You know 0, but you use what? NCB delta. So 1 to A, you must know the temperature here. Okay. So you write this way. NCB. What is this? For 1 to A. Write this. I write this way nicely. 1 to 2 prime. Again, here, what we write? Delta U, step by step. 1 to 2 prime, 1 to A to 2 prime. So 1 to A plus delta U A to 2 prime. Okay, good. So now remove this. Now remove this. A to 2 prime. Acha, suppose A you don't know. Suppose I'm saying you don't know. What is this? NCB, tell me delta T. I know the answer. Don't worry about the answer. Okay, because we consider answer is isothermal, so 0. But you write this as simple. TA NCB delta T. TA minus T1. I don't know T. I will not find out. You may not find out. You may find out. But you know this is isothermal. T. Plus what is this? NCB. Tell me. T2 prime minus TA. What you get out of this? NCB T plus T2 prime minus same as this is delta U1 to 2 prime. Okay, you write here, please write here, don't change, little bit change. 1 better 1 A 2 prime as different from delta U1 2 prime, the adiabatic. Note, and we know compare with what? Direct 1 to 2 prime means adiabatic, reversible adiabatic. What is that? Delta U 1 to 2 prime. Not value, I am not asking. The expression gives, you can substitute the values. Okay. What is delta U 2 prime is what? N CB T2 prime minus T, same result. Same. So you are full satisfied. Here you may find out T. Okay, this. Achha, start. Other options. So this. Happy? Next is 2. What is this? Okay, isothermal followed by, so constant volume followed by isothermal. Isothermal. What is the answer? Follow constant volume. How shall I get? Constant volume is drop. Drop where? And isothermal. So die drop. Then where is the isothermal? Where? I have to reach here. That means an isothermal process involving this. So that means this is called isotherm. So you have an isotherm for each temperature. What is the temperature? Tell me. A moment ago I have done. What is the temperature for this? 1800. 100. Oh. Tell me. 118.4. Sorry. Okay. It is unnecessary. I know myself. 18.6. 6 Kelvin. Follow this. Isotherms is isothermal path. Isotherms are isothermal path. So this is already one isotherm. What isotherm? Tell me which isotherm? This is at the temperature 298 K isotherm. What is the appearance? What does it look like? Rectangular hyperbola. PV is constant. Isotherm. So this is the, and other isotherms are parallel to it. All isotherms are parallel. Now currently this is another, for each temperature there is isotherm. Each temperature. Like this, okay? PV is RT. R times that particular temperature is the PV value, is rectangular hyperbola, you know. So this is actually PV isotherm. Then this is what? Parallel. Faint line. Not bad. So what is this? Tell me. What is this? This is, sorry. This is what? 118.6 Kelvin isotherm. Happy? This is isotherm. Okay. So all isotherm. Similarly, other isotherm. Can you guess? See another thing. Not only parallel. Suppose which are receding, going away from the origin, they are greater in temperature. So this is 298, and this is closer to origin, less. So it is 1000 Kelvin will be somewhere 2000 parallel. Okay, good boy. So now do the rest. So it is better I use this colored chalk. So how this is on white already. So constant volume. So while you will hit, you say constant volume, drop vertically drop. Drop until it hits this isotherm. Okay? Because then I will show 1, 8, 2, call it B perhaps. 1, B, and then I am giving this 1, B, 2 prime, 1, B, 2 prime. 1, B, 2 prime leads you 1 to 2 prime. Same as, gives the same result for state function change. that we get with 1 to 2 prime. Okay, so 1 b 2. This is constant. So let me write here. 1 b 2 prime. See, note 1 2 prime, 1 2 prime everywhere. 1 2 prime. Okay, happy. So very good, very easy, funny problem. Okay, enjoyable. C is what? Third is what? There are other options. You can suggest something. Something, sir, many ways, sir. Play with this. I should suggest what is the first one? Constant volume followed by this is okay. Next is what? Achha, this problem. Let us go by the problem. Problem is what? Isothermal followed by constant. Very good. Thank you. So third, you try. Isothermal follow. So I have to reach start. Starting is at finish here. Isothermal. So isothermal, okay. Starting here, isothermal means good, very good, very good. Where shall I stop? Constant pressure is horizontal. Constant pressure is a horizontal line. Constant volume, vertical line. Horizontal line means, horizontal. Up to this point. So this is the point. 1, 2 itself. 1 to 2, then take a turn, horizontal line 2 to 2 prime. This is the path. So write that nicely, as you said. Isothermal followed by tell me what? Constant pressure. So you also according to constant pressure. What is the path? 1 to 2 prime. Happy? Okay, very good, very good. Isothermal. Then third, fourth, fifth, this side maybe, or maybe that side. Fourth, fifth, fourth. Let's start this. Start. The other side. Start. Fourth quickly. Constant pressure followed by constant volume. Okay. Everything constant pressure. Constant pressure followed by constant volume. Okay. What is this? Take a look. What is the problem? Constant. Fourth one.
Constant volume followed by constant pressure.
Oh, constant volume by constant pressure. Constant volume. Try this. Acha, tell me again. Now you are smart. Now you are actually. What's the constant? Start here. I'll end just constant volume means vertical. But until when? Here. I'll stop here. I'll stop here. It will be followed by constant pressure, horizontal line. That means. This is the one, sir. 1C, 2 prime. So color chalk not bad. Oh, this is not colored. 1C, 2 prime. So what is the path? Right here. Constant, as it says, constant volume followed by constant pressure. What is this? 1C, 2 prime. Again, I will show you once more. Delta U. Same as follow this with me, and then I will take up the last one. Again, start. Suppose delta U, sir. Delta write nicely. Delta U 1C, 2 prime. Follow this. It's a lesson for you. Follow it. Okay. What is delta U, sir? Is delta U 1 to C plus delta U C2 2 prime. I know temperature delta means NCB delta T. NCB delta T. So write NCB irrespective of the path. There's a great advantage with ideal gas. TC, I don't have to find out, calculate TC minus T1 plus NCB T2 minus T2 prime. Achha, right here. Plus NCB T2 prime minus T2 prime. Also T2 prime minus TC. You do this, NCB T2 prime minus T1, it is same as delta U 1 to 2 prime. The reversible additive. Same. Okay. Very good, very good. Last is what? Third. Last is? Is the last one. So for fifth, remove this fifth here. Fifth, last one. Constant, obviously constant pressure followed by constant volume. What is the path? Path is, let us draw this. Let us see. Some of you should try. Let us see. Somo will try. Somo. Constant pressure followed by constant volume. Somo, will you try? You like to try? Oh, white chocolate. Do second. Constant pressure means constant pressure means horizontal. You go horizontal. So horizontal. Where? Your destination is this 2 prime. So you say draw. So like this. So as if you extend this 1D and then the up to all the way to 2 prime. So what is this? Path is 1D. Try this. Problem next. Problem 3 is actually is all over. Remove this. Quickly and very quickly. Problem 3. This I say I could not actually. This problem actually. Okay, very good. Start. We start. What is the problem? Actually, I have to write the problem. One mole of an ideal gas. Start right. 1 mole of an ideal gas is heated and compressed. Who are talking? Very bad. Okay. You cannot answer questions, or you are actually fooling around here. Okay. Answer the questions, then and be serious. 2 6 and 4 atmosphere. Throughout this step, what happens? This relation holds. T is T by 300 square. Step 1. This is actually one thing. This is, I say, acha. Oh, no. Heated and compressed, I say, starting another is, I'm very sorry, is, acha, I'm very sorry, I don't want to waste this. Right, is, you insert here, is, you write here, is what? Is carried out through the, is carried out through the following reversible cyclic process. Through the, what are you talking? Oh, you have got this copy? Problem sheet you have got? What is the problem sheet? So what are you talking about? Through the following reversible cycle. Cyclic process cycle. Okay, it's okay. So this is right, is carried out through the following reversible cyclic process. What is the step 1? Step 1. Sorry, very sorry. Step 1 is starting at 300 Kelvin. Very bad. Step 1. The average. Starting at 300 Kelvin. Step 1, starting at 300 Kelvin and 1 atmosphere, is wasting time. And 1 atmosphere, the gas is heated and compressed. The gas, just add the gas, okay. The gas is heated and compressed. I'm very sorry. Huh? Yeah? Step 1, starting at step 2. Step 2 is what? Step 2 is what? I'm very sorry. Step 2 is at a constant, the way it is written, step 2, this is written this way. At a constant temperature of 600 Kelvin, quickly, 600 Kelvin, the gas is expanded from P is 4 atmosphere to P is 1 atmosphere. Third is what? At a constant pressure of 1 atmosphere, the gas is cooled (600 Kelvin) cooled to 300 Kelvin. Did you have this problem with you? Did you try these problems? Which problem did you try?
Yeah, this one.
You tried?
No, sir.
Why no? It was given not for trying,
Sir,
for not trying. Huh?
আগের ক্লাসটা করা হয়েছিল না তো
This is find. Now question is find delta U, delta H, Q and W for each of the 3 steps. For each of the 3 steps, and for the cyclic process, given to you, Cb is 3/2R, means monatomic ideal gas. Good. So solution, let us case this problem. The starting, suppose this is 40 starting, what is this? Step 1, starting is, okay, 1 mole gas, starting is 300 Kelvin, 1 atmospheric pressure. So this is 1 atmosphere. This is 1. So this is starting, okay, I'm very sorry, this is 1. This is your 1, okay, sorry. This is 1. This is the starting, okay. What is this temperature and pressure? 300. What is the volume? Volume is what? B1, okay, this state 1. Volume, quickly calculate here somewhere. Calculate here. B1 is maybe not bad. B1 is what? P1 NR T1. So B1 is what? N is what? How many moles? 1. R 0.082. T1 is what temperature? What temperature? 300 Kelvin. 300, say starting. See, starting at, underline, 300 Kelvin. 300, pressure is 1 atmosphere. So this gives you what is the volume? 24.6 liter, right here, 24.6 liter. So I'm writing somewhere, for clarity, I'm writing somewhere, okay. I'm writing somewhere, where I write, maybe here, Call it state A. So this is the 1 to 2. Okay. Okay. 1 to step. Okay. State 1. State 1. Achha, since actually I have used this state 1 or state, okay. Step 1 or state 1. Okay. This is step 1. So call it. Okay. Very good. Very good. Okay. Oh, state 1. What is this state 1? Tell me. Temperature, pressure, right? P1. Right here. How to write this? State 1. Write this below. State 1. Keep the pressure, volume, temperature. Pressure is what? PVT. Pressure is what? P1 is what? Tell me. Pressure is what? 1 atmosphere. Volume is what? Right? A moment ago, 24.6 liter. And T1 is what? Remove this. This problem you have written. Sorry, actually I have removed the problem. Not good. Actually, T1 is what? 300 Kelvin. State 2. State 2 and state 3. State 3. State 2, what you know? Okay, is compressed, heated and compressed to 6. Temperature you know 600 Kelvin. Is given 600 Kelvin. What else given? 600 and 4 atmosphere. I am very sorry that I have removed that 4 atmosphere. So what will be the V2? V2 thing. I mean it's bad. P3, V3, T3. T3 is what? What is this? Third step is what? Third step, I remove this third step myself. Okay. What is this? Constant pressure. What is the constant pressure? Means what? 4 atmosphere. And temperature is what? Okay. This is cool to 300 Kelvin. Constant pressure. What is the V3? V3, what is the volume? Achha, cool. Let us do this quickly. What is the V2? Achha, draw this. Draw this. 1 to 2. 1 to 2, 1 is okay. This is the starting state 2. The path is, what is the equation of the path? Right? P is T by 300. Oh, there is no space, you know. There is no space here. Okay. Right somewhere. Here. P is T by 300 square. This is 1 to 2. This is the path. Second path is what? Then it is, see, second path is, I should have not removed this. This is what temperature? P2 is what? What temperature? 4 atmosphere, 600 Kelvin. 600 Kelvin. Write this. 600 Kelvin. Then it is isothermal. 600 Kelvin. What is written there? Second step, constant temperature means isothermal. From P is 4 atmosphere to 1, back 1. Second path. Third path is what? Constant pressure. Okay. So this is the third. Follow quickly. 1, 2, 3. 1 is actually everything is given volume you have to find out. You have found out volume. Okay. 20 I have given. P2, second is this is a path we are not familiar with. This is a new path. It is neither adiabatic nor isothermal, not constant pressure, not constant volume. Different. You can see this relationship holds. So, but anyway, this is reaching here. 600 Kelvin. What is the volume? Volume you can find out. How you get the volume? Can you tell me volume quickly? You can get. Tell me volume here. Can anyone? See 1 to 2. See pressure has been 4 times. Pressure 4 times means if temperature did not change, what is the volume would be 1/4. But temperature has changed. Temperature has changed to 300 to 600. 2 times volume should increase. 2 times if pressure does not change. That means 2 times increase, 4 times decrease. It is actually half. 12.3. You can get it from where? Also PV is RT. P2 you can get from V2 is, if you want to get V2 is, tell me. T2 NR. T2 you do yourself, but you will get this. B2. B2 is okay. P3 is 4. I'm very sorry. 1. Thank you. Thank you. Constant pressure 1 atmosphere. Very good. Very good. Okay. So what is this part? Isothermal part. This is isothermal part. So this is state 2 to state 3. This is isothermal. So what is the volume? Guess. It is what is happening here? 4 times down pressure. Temperature. T1, T2, 600 Kelvin. 600 Kelvin. This is isothermal. 2 to 3 isothermal. So 600. Right? 600 Kelvin. Right? And this state 1 temperature 300 Kelvin. You can guess. See, here you see what is the volume it will be. Tell me. Because 600 pressure has been what? Pressure same pressure 1/4 means volume 4 times. Sorry, it took time though, but you complete this or you may write here. Sorry. Okay, very good. Now quickly complete. Things are over. Is written everywhere there. So start. What is the work done? Work done W1 to 2. Work done W1 to 2. Say this part I will discuss next class. I am very sorry that I could not complete. 1 to 2. How will you do? 1 to 2. 1 to 2. Want to think about this? Let me know. How will you get? Tell me. PdV, sir. Integration PdV. This is the answer. Reversible path, integration PdV, sir. This much you know. From 1 to 2. But what is the relation between P and V? So this is given. So from that. P is right here. P is T by 300 square. Quickly. T by 300 square means what? T is what? PV by R. 1 mole. PV by R. 300 R square. That means P square by 300 R square. That means all PV square is 300 R square. This is the equation of the path. This is the equation of path. Alternatively, this is the equation of the path. This will be useful because PV relationship you are required. So PV square, this looks like what? Compare. It's a strange, unusual path. How this path is performed, I will let you know next class or if time permits today. So, but compared to adiabatic, it is close to adiabatic only to some extent. It is different path, but it is, if any resemblance it has with the 4 standard ideal, it has some closeness with the adiabatic. Compared to the adiabatic, to the reversible adiabatic, what is that equation? Tell me. P V to the gamma. Gamma is 1.67. Is constant. And this is what? Is constant. You might write constant here. So PV square is constant. PV to the 1.67 is constant. It is not adiabatic. And not to speak of isothermal constant pressure, constant volume. So this is totally new path. But as far as problem solving is considered, it is in time, correct. Okay, as problem solving is considered, you have no difficulty. You do yourself now. Integration, what is this? Why I started? See, P is what? What is this? I am getting you started. 1 to 2, what is P? 300 R square. You do yourself. By V square dV. What is the volume? 1 to 2 means? Tell me. V1 to? This is all about V. Now you can integrate. PV relationship you can integrate. And that you have. Okay. So do yourself. W. Next class you will come up with the answers with the complete. 1 to step 1 to 2. Where I wrote step 1 to 2. Okay, anyways, that you will try to complete the problem. Okay, solve the problem. Okay, what is this? For each of the 3 steps I follow cycle. W, you get this TU and delta U, delta H. This okay, see, use this. For example, delta U, what will you answer? Delta U for this, what will you answer? NCB delta T all ideal gas. Delta T sir, 1 to 2. T2 minus T1 NCB. Delta H likewise. So Q is there, yeah, so W is there, then Q is what? This Nidjar will tell. Q will be what? W I have shown you. So Q will be what? W plus delta. So you do know W and delta U? Why? How do you know? How do you know then? If W a moment ago I said, is it? This you can do, this integration W and delta U is what? Delta U is what? Huh? NCB delta T. So this I said also, but delta T is what you know? Delta T what?
T2 minus Q.
T2 and T1 is there. So, okay, you can. So complete this list. Yeah? Complete this problem. Then you save time tomorrow. Okay, thank you. Quickly, just thank you. Thank you. Today we are actually winding up the class here. Okay, let us call it.